Hello, good day. Once again, welcome to my YouTube channel. And for today's video, we're going to be discussing about vector. This is in continuation to the previous topic, which is the scalar and vector. Right now, we're going to discuss again the vector and also its application, or how do we solve vector. Okay, so first and foremost, let's review what is vector. So we remember that vector is composed of its magnitude and direction. In comparison to the scalar, scalar is just a magnitude. So right now, we're focusing on the magnitude and direction of the vector. And to tell you, in the application of vector, we consider some numerical solutions. Okay, but those solutions will be very simple. Okay, so vectors are usually or commonly represented as arrow, which tells that it has a tail and a head. Syempre, we're talking about the magnitude and the direction. That's why it is always represented with tail and head. Okay, now a vector's length and direction should be drawn to emphasize the magnitude as shown. So if you're going to compare two different magnitude, let's say a force. So you can see here that this arrow represents, or the longer arrow downward represents a bigger or a larger magnitude compared to the smaller magnitude of an arrow with a magnitude of 10 kilonewton going upward. Okay, so that's it. Moving on. So we have applications of this vector. So we call that one as addition. Okay, so the action of combining, this is the action of combining two or more vectors into a vector sum, or commonly known as resultant. Okay, later on I will discuss to you about what is resultant, which is also known as vector addition. Now, simply add two vectors that are pointing in the same direction. Okay, so as you can see here on our screen, so there are two connected arrows that are pointing at the same direction. Therefore, these arrows can be added and are an examples of vector addition. Okay, there are, as I've said a while ago, vector addition is always represented with R, or the so-called resultant. Okay, so adding them, A or vector A plus vector V, gives you a resultant vector. Okay, there are three methods that you can solve in vector addition. The first method is the head to tail method. Secondly, the parallelogram method. And thirdly is the component method. The head to tail method is already being presented to you. So this one is the head to tail method. Just combining the two vectors that are pointing the same direction. Okay. Let's move on with the parallelogram method. Now, in this example, please disregard initially, as what you can see here, the vector that is represented by A prime. Okay, let's say that the original vectors that are given in this problem are just these two vectors. Okay, now let's assign this with our A, or with our vector A, and this one is our vector B. Okay, this is your vector B. So that's the first diagram representing this problem. Now, in parallelogram method, to get the resultant of these two vectors, simply connect or make a parallelogram. Just make a parallelogram. You just have to connect an opposing or relative lines. Relative lines, it's because of the vector magnitude here must be congruent or equal to the magnitude here. Okay, same with the B. Okay, so let's assign this with our vector. Let's say this is your A, vector A prime, and this is your vector B prime. Okay, that's it. Now, if you're going to get the resultant here, the resultant vector or the vector addition using the parallelogram method, simply get the value here. Now, to get the value here, okay, the resultant, just simply take A plus B. So this is just an imaginary line, this A prime vector and then the vector B prime. Okay, so as you can see, let's get back. The head to tail method is being applied in the parallelogram method. So in conclusion, the purpose of the parallelogram method is just to make an imaginary lines related to the first two original vector, just to see the parallelogram figure, and then you will arrive, or you can see now in conclusion of the line or the vector of the resultant, and then move on with the solution of the resultant, getting A plus B. Okay, next. The third method is the component method. So here in the component method, we can use what we have learned during our trigonometry the course, okay, the right triangle principle. Okay, so a single vector quantity can be broken down into two or more scalar quantities using vector components. So we represent, usually, if you are given with this R here, okay, R, you can see the R, and then an inclination, there is a direction of that magnitude R, or vector R rather. So what you need to do is to apply the component method, and then you represent in the Cartesian coordinate x and y, you represent resultant of x, that you can see on the line x, and then resultant component y to the coordinate y. So here you have formed a right triangle. So therefore, you will now apply the right triangle principle as you have learned during your trigonometry course. Okay, to get the relationship, simply write Rx is being equal to the R cosine. So this one here is cosine of theta, and then the Ry, okay, Ry is equivalent to the R sine of theta. So here I will draw to you the initial vector R. Again, if you're going to get the magnitude of this, you have to consider the theta. Okay, that is why you will draw an imaginary or a broken line representing your Ry, and then a broken line representing your Rx. And then again, you will arrive to this formula. Okay, we remember that tan theta, okay, your theta here, the relationship of theta is with Ry all over Rx, and then you're going to get tan theta is equivalent to Ry all over Rx. And then theta will be equal to arctan of Ry all over Rx. Next, so I will give to you an example of getting component or solving component method. So a ball is thrown with an initial velocity of 70 feet per second at an angle of 35 degrees with the horizontal. Now find the vertical and horizontal components of the velocity. Now to get this problem easier, you'll need to draw the vector. So since it is given with a magnitude of 70 feet per second, okay, with a direction of 35 along the horizontal. Okay, if this is your horizontal line, x, and this is your Why, I'm sorry with my penmanship. Okay, this is your theta along, okay, or with the horizontal at 35 degrees. Okay, if you're going to consider the values of the vertical and the horizontal component, simply just represent it with your broken line going vertical, and then here is going horizontal Rx. Okay, outside, and this is outside. Next thing to do is to solve for its value. Okay, since R is given at 70, okay, or feet per second unit. Now, simply remember that Ry, okay, if we're going to get first the Ry, or the vertical component, Ry is simply equal to R sine of theta. Okay, what is R sine theta? If your answer is 70, sine of theta, that's, or sine of 35 rather, sine of 35 degrees, that's that is equal to 70 sine of 35 is equal to 40.15. Okay, of course, you need to provide your unit so as to evaluate a right answer. Okay, so the unit is in feet per second. Okay, that is your answer, 40.15. Now, to get the x component, answer is Rx is equivalent to 70 cosine of 35 degrees. So, answer is 57.34 feet per second. So, that's it. You now have the correct answer. Again, you need to provide unit to make your answer correct. Next one. Okay, this one, the example 2, I will leave this, or I will stop the video for now, and I will leave this an assignment to you, and then I will provide a YouTube video again for YouTube video on how to solve this problem. Now, the problem states that two forces F1 and F2 with magnitudes 20 and 30 pounds respectively act on an object at a point P as shown. Find the resultant forces acting at P. Now, it's for you to answer this problem, and then again, I will provide a next part of this video solving this problem. And for your reference, just see these links. Okay, so I hope that you have understood what understand what I have presented right now, and thank you for your time, and God bless us always. Bye.